Hello and welcome to Kweku Online Study. Today we want to talk about past questions on AP, that is Arithmetic Progression, and then Geometric Progression, GP, right? So we are going to solve questions that have been in the past papers for a while now to fully understand the concept so that in exams we can really score and score well. So at this point, if you haven't subscribed to the channel yet, please do so for more videos. Now, before we start, I want to show you something. If you have a classic paper like this is from May, June 2021, there's always what we call the mathematical formula sheet, right? And then if you look at the formula sheet, you realize that you have a portion for binomial theorem all the way to GP, all right, or the geometric series. So the point I'm trying to make is that all the formulas that you need are going to be available. The formula for the n term, the formula for the sum of n term for AP is there, the formula for GP is there, the formula for sum, and then the formula for sum to infinity. They are all there. Even the binomial theorem formula is also there for you. So basically, with this topic, I wouldn't urge you to memorize anything. Just go in the exam room, look at the formula sheet, get your formulas, and then you just work with it, all right? So now let's go back to our worksheet and then give it a try. But this worksheet is in the description below, so you can download it and work alongside with me. So let's start with the very first question. It says that a GP has the first term to be what? 10, right? So that means that, remember that the first term is A. We denote that by A, so A is 10, and then the sum to infinity is 6. But what is the formula for sum to infinity? Is sum to infinity is equal to A over 1 minus R, right? And we are saying this is what is 6. Fine, but we said that A is 10, so we have something like this is equal to 6. And what do they want us to find? Find the common ratio, that is R. Okay, so that means that we have 10 is equal to 6 into 1 minus R, which is 10 equals 6 minus 6R. So we have 6R is equal to 6 minus 10. What I did was to bring this one here and then bring this one there. Okay, so yeah, 6R, 6 minus 10. So you have your R is equal to negative 4 over 6, which is the same as negative 2 over 3. Okay, so that is your common ratio for 2 marks. Then the question goes on to say that, hence, find the sum of the first 7 terms, giving your answer to 2 decimal places. Well, sum to n, all right, for GP is basically A into bracket 1 minus R to the power n over 1 minus R. All right, now A is 10, R is negative 2 over 3, right? They said the first 7, so n is 7, all right, all over 1 minus negative 2 over 3, right? So you can just put it on the calculator, and then let's see what we do get. So that's 10 into bracket 1 minus into bracket negative 2 over 3 to the power 7, all right, over 1 minus into bracket negative 2 over 3. So that's 6.3512, but they said they want 2 decimal places, so 6.35. all right, and then we end here. So that's it. So the B part of the question says that the first 3 terms of an AP are these, all right, AP. So we should find the common difference. Well, the common difference is basically this term minus that term, or this one minus that. Regardless, I mean, whatever you choose to use is fine. So I will go with 3 square base x, okay, with this one. And that should give us 2 log 3 base x minus log 3 base x, giving us log 3 base x. All right. Okay, so that's our common difference. And then we are told to find, in terms of n and this, the sum to n. All right. If you consider the formula, it is this particular one, right? So, I mean, the formula is just there. So that's the formula. Sum to n of AP is n over 2, 2a plus n minus 1d. All right, so this is the formula that you are going to use. And you know your first term, this n over this, your first term is log this, okay? So keep that in mind. And your common difference is also log 3 base x. All right, so we are basically going to simplify what we have here. This is n log 3 this. You know what, I would rather hold on because I can see something coming up. I'll expand that particular bracket and then see this and that will subtract easily. All right, so that would be we will have this 3 plus log 3 base x. All right, and then we can further simplify that. That should give us log 3 to the power n, okay, base x, plus log 3x. If you combine this, you should have log 3n plus 1 base x. This is because if we're adding two logs, they're actually multiplying. And when they are multiplying, you keep the base and you add the powers, okay, from indices. So this is what you have. Okay, now I believe we can even further simplify this. It should be 1. Okay, check this thing out. This same thing can be written as, that is if we want to, I mean, really simplify. This has to come up, all right? Remember that it's a law in log. So you have this, okay, all times this, okay, base x. So that means that really you are dealing with something like log 3. I know it's just 2 marks and I'm sweating over it, but like, who cares? Okay, over 2x. So if I like, I can now bring this guy down to have something like this. Yeah, so I can end this way. It's all about algebra, playing with things. But truth be told, if you were to leave your answer at this stage, let's say at this very stage or this stage, I mean, you'll still score, okay? So don't worry about to what extent should I stop simplifying. It doesn't matter. You just put a few things together, that's it. Now they are saying that given that the sum to n is this, find the value of n, right? But remember that what we have here is our sum to n. So our sum to n is actually n into brackets n plus 1 over 2 log 3x, right? This is equal to this. So I just multiply 2 by 2, you know, so that I'll get rid of this 2, that I can write this. And 30, 81 times 2, that is 61, 62. All right, and then let's see, how do I find my n? Okay, hold on, let's see. I can write this as that. Right, okay. And then I can write this as this. x to the power this, right? Okay, now the next thing that we can do is to kind of, let's see if there's, oh, okay, I left something out. So let's see, what did I leave out? See, they said that it is equal to this is included. I left that guy out. That's what is making the work hard. All right, so we have to go back. So let me clean all this. All right, sorry about that. So we can include this guy. So that even if I'm multiplying by 2, I still get my n plus 1 log 3x is equal to 6162. All right. Now, the next thing that happens is that if you check out, this guy is the same as that guy. So we have this is equal to this. All right. Then the next thing that we can do is to solve this as a normal quadratic. And if we put it on a calculator, n is equal to 78 and n is equal to negative 79. But we can't take the negative answer, so our n is basically 78. All right, so that's how we go about it. Then the next thing that they are telling us is that the sum to n is also equal to this. Right, remember that this is our sum to n, so we can just write it there. They said it's equal to this, so we should find x, but we know n is 78, so we have 78, 79, because n plus 1 is 79 over 2, this guy is equal to this. Okay, so we can just simplify this guy, right? 70, let's say 78 times 79 over 2, that's actually 3081, all right? Okay. Then the next thing that we can do is to, write 3 log 3 to the power 3081. Okay, this is equal to that. So that we can write this is equal to x to the power of this. All right, so let's see what we can do here. If we, all right, this could be huge for the calculator. So before we redo it, I just want to give it a try before I think about another step. I can decide to multiply both sides by 1 over this. Okay, so that I can find just x. It's a way that we get out of trouble in maths. But if I do 3081 divided by 1027, I get 3. Good. So this is 3 to the power 3, all right? And this is x, giving me 27. That is smart. So we can use that approach to go about it, all right? Even though s to the power, a huge number, just do 1 over that number. I mean, get rid of the x, and then you are able to continue doing the maths. So that's x should give us 27. All right. So this year is May, June 2021, paper 2-1. All right. So what do they want us to do in this problem? They said that the 2nd, the 8th, and the 44th terms of an AP, I mean, that would form the first 3 terms of a GP. So how do we go about it? It says that in the GP, the first term is 1, and the common difference is positive. Okay, these are things we can keep in mind, right? All right, so for the second term for AP, that will be A plus D, right? If, let's say you've forgotten the formula, okay, so let's remind ourselves of the formula. It's A plus N minus 1D. So for the second term, you have A plus, if you put N is 2, so 2 minus 1 is 1, then you have D. Then your 8th term will be n plus 7d. And then your 44th term will be a plus 43d. Now these will go to form, all right, this is under GP, these will go to form the first 3 terms. So that is a plus, even they said that the first term is 1, all right? Let me not skip it, it's 1 here, all right? I hope you can see it. Let me clean it, this part, and then use red to circle it. That first term is 1. That means that we can change our thing to 1 plus d, 1 plus 7d, 1 plus 43d, because first term is 1. So under the GP, we are going to have 1 plus d, that's our first term, 1 plus 7d, second term, 1 plus 43d, that's our third term. And what do they want us to find? We should show that the common difference is what? Is 5. Okay. Now this is it. For a GP, the common ratios must be the same. So this term over this is the same as this term over that. Okay, so let's do that. So we have 1 plus 7d over 1 plus d should be the same as 1 plus 43d over 1 plus 7d. And then we solve this, all right? So we have 1 plus 7d. Well, I'm going to just cross multiply, this time that, this time this. But since it's the same thing, I just square it. And then I have 1 plus d and then 1 plus 43d. So this would all be, let me expand it right here. So we have 1 plus 14d plus 49d squared. And then we can expand the other one. We have 1 plus 43d plus d plus 43d squared. All right, so we can group like terms, and then this 43d squared comes to subtract from this. So you are going to have 49 minus 43, that should be 6, right? So 6d squared. And then we have these two d's here will become 44, right? So you have basically 14d here. So 14d minus 44 will give us negative 30. And then we have, finally, let's see, we have the negative, we have 1 here, we have 1 there, so go to subtract, that's 0. So you can factor d out, so or we can actually factor 6d out, and that means we have d here minus, that's 6, 5, 30, so 5 is equal to 0. So that means that 6d is equal to 0, or d minus 5 is equal to 0. All right. And then that means that d is equal to 0 or d is equal to 5. They said that d is positive. Okay. And now the common difference between any progression can't be 0. Of course, then that means that the same number is repeating throughout. Therefore, our d is actually 5. Okay, like that. Okay, so you found your for 5 marks, yes, because this is a lot of things that you are doing. Then they said that find the sum of the first 20 terms. Well, just in case you've forgotten the formula, we can always go back. Sum of n terms is here. All right, so that's it. You just keep it in mind, or you can always go back to your formula sheet, and then you should be fine. Sn is equal to a into bracket 1 minus r to power n over 1 minus r. Now our a, remember, is the first term, and then we are told that the a in this story is basically 1, right? But for this GP, it's a GP question. Okay, no, they actually want us to work with the AP, so I have used the wrong formula. All right, so let's clean it. I thought that we are still working on the GP, so let's clean it. So, if I am making mistakes, then you can make mistakes, and we are all human beings. So just make sure that you are paying attention to the kind of progression. So you can go back to the formula, check the AP sum formula. Okay, so this is the sum formula. Keep that in mind. Okay, so we go back. So that's n over 2 2a plus n minus 1d. Okay, now they said that first 20, so n is 20. A is 1, that's the first term. And this will be 20 minus 1. And common difference is 5. So we can just put this on the... Let's simplify before. That's 10. And we have 2 here. And we have 19 times 5, right? Yeah, then we can just put everything in the calculator and then we'll be fine. 19 times 5 is actually 95 plus 2 times 10. Then we should get 970. At least that's what my calculator is saying. All right, so we continue. Now, what do? They said that find the fifth term of the GP. Right, the fifth term of the GP. So how do we basically do that? GP is A, R, N minus 1. All right. Now, your GP is different because these are the sequence. Let me even copy it here. The first 3 terms are these. Okay, these are the first 3 terms. And you know that D is 5. So that means you have 6. And then you have 1 plus 7 into 5. That's 36. And then you have 1 plus 43 into 5. That is 216. Okay, so your first term is actually 6. And then the common ratio, have we found it? I don't think we have. But we can always find it because it's this over that. So common ratio is 36 over 6, giving us 6. So R6, then they say the fifth term. So that means that you have 5 minus 1, which is 4. So basically you have 6 into bracket 6 to the power 4. And that should give us 7776. All right. And then you are done. Okay. The next thing that they want us to do is to explain whether or not the sum to infinity of this progression exists. Okay. So we need to give a very valid explanation. The sum to infinity formula is, let's go for the formula. The formula will help us to explain it well. This is the sum to infinity. All right, so that formula says A over 1 minus R, and then the absolute value of R should be less than 1, right? Okay, so we have A over 1 minus R, given that the absolute value of this is less than 1. Okay. What is our common ratio? Our common ratio is 6. Right, we are supposed to get a common ratio less than 1, but our common ratio is 6, which is greater than 1. So what can we say? Well, we can say that the sum to infinity, okay, sum to infinity does not exist. Why? Maybe for this GP, okay, for this GP. Why? Because the common ratio, all right, common ratio is greater than 1. You are done. Because you got a common ratio of 6 instead of something that's less than 1. Therefore, it doesn't exist for 1 mark. All right. So the next thing that we want to talk about is a paper that came in, also major in paper 1, 2. All right, question 9. It says that the first 3 terms of an AP are these. Okay. Find the smallest number of terms for which the sum, all right, of this is greater than that. Well, you remember that the sum formula is this. And they are saying this is greater than 2,000. Okay? So what this means is that we need to find our A and we need to find a D so that we can find the smallest number of terms, that's n. We have -4, 8, 20. They said is an AP. So common difference can be 20 minus 8, giving us 12. And then we know A is -4. That means that we have n over 2 into bracket, 2 into -4 plus n minus 1. Common difference is 12. All this is greater than this value. So we have n into brackets, -8 plus 12n minus 12 is greater than this. So we can further simplify what's in the brackets. We have 12n minus 20. All right, so you can multiply by 2. So you have n, then you have 12n minus 20. This will become now 4,000. Then you can expand. So you have 12n squared minus 20n is greater than 4,000. Okay, now get it in a nice quadratic form. I'm just going to use the calculator to do it. Okay, because I am not teaching quadratics. And I believe that you can solve a quadratic equation at this stage. So you can use the calculator to confirm, or you should actually solve it out. Hold on. So we have the first term is 12, followed by negative 20n, then minus 4,000. I'm getting weird values here, but anyways, I'll work with it. So I have n to be 19.1, and then I have another n to be negative 17.4 actually. Okay. Now, I will just hold on to this thing for a minute. All right, let's put it right here for a minute. So you can say that, you have your two n values. Remember, when you find your n value, this is a quadratic inequality you are solving. And this is actually a U-shaped. So you are going to find something like this. And your negative value is here. And the positive value is here. 19.1, sorry. The question says that it is greater than 0. That means that we are interested in the part of the curve that's above the x-axis. So we can't deal with a negative value, all right? This negative value is just out of the discussion. So let's look for how to write the inequality for this. This would be n is greater than 19.1. All right, then we go back to the question. It says find the smallest value for which it will be greater than this. So the smallest value of n, and n is an integer, would be 20. Okay, the first value bigger than 19.1 is 20. So your answer is really n equals 20. And you do all this for 4 marks, all right? Then we move on to the B part. The B part says that the 7th and the 9th terms of a GP are this and that. So find a common ratio, no problem. The 7th would be AR to the power 6, all right, because it's n minus 1. This is 27. And then the 9th would be AR to the power 8, right, is equal to 2, 4, 3. All right, and they said that find the common ratio. So what you do is that divide the two terms. So you can do ar to the power 8 over ar to the power 6 is equal to 243 over 27. A cancels A. This will simplify to r square. And let's see, if we do 243 divided by 27, we will get 9. That makes r to be 3. Right. Okay. Then they said that the 30th term, we should find it. And we should give our answer as a power of 3. No problem. So U30 will be equal to A. In fact, we have not even found the first term. But we can find it, right? I mean, we know from this side, we can use this to find it. So that is, let me find the first term before we even continue solving the question. So we have R is 3. So we have this equals 27. So we can have this is equal to 27 over 3 to the power 6. And that will be a very not nice number. So that's 1 over 27. So that's A. So U30 will be equal to A, which is 1 over 27, times R to the power 29, right? Now, 1 over 27 is the same as 3 to the power negative 3, right? Times 3 to the power 29 should give us 3 to the power 29 minus 3, that is 26, right? Yeah. So this is our answer, 3 to the power 26. They said we should give it as a power of 3. So that is what we do. And then they want us to explain why the geometric distance within this interval, where theta is in radians, has a sum to infinity. Okay. Now, if you haven't done trig before, then I'm sorry, you can skip this part. But if you have already done trigonometry, then we can have the conversation. Remember that the sum to infinity of a GP is A over 1 minus R. Okay? Now, from this sequence, all right, your common ratio is this term over that term, right? So R is sine theta over 1 giving us sine theta. So this equation really, and then the first term is also 1, so it changes to 1 over 1 minus sine theta, okay? So now this is what we have. We also know that sum to infinity is true when the absolute value of R is less than 1. In this case, we can say when the absolute value of sine theta is less than 1. Right. Okay. Now, how do we, argue whether this is true or not? See this. We have sine. If this is supposed to work out, okay, let me just use this blue marker to highlight. If this is to be defined, then we must ensure that sine 1 minus sine theta is not equal to 0, right? But let's say that in this case it's equal to 0 to see that it is not defined. If it is equal to 0, then you have sine theta giving you 1, right? So theta is basically sine inverse of 1. Remember that you are in radians, so quickly you change the calculator to radians. And then you find sine inverse of 1. And then calculator will tell you that your answer is pi on 2. Okay, it's pi on 2. Now, if you check, the angle that we are dealing with is between pi on 2 and then negative pi on 2. So that basically means that our angle, okay, we said if it is equal to 0, then we'll have sine to be pi on 2. But it is not equal to 0. So that means that sine is not going to be pi on 2. And that means that this thing is actually defined. So the sum to infinity indeed exists. Okay. All right. If we had gotten a value which were making the denominator 0, then that would have been an issue. Like the theta makes the denominator 0, that would have been an issue. But I mean, the denominator, obviously, we are not going to get a 0. Okay, it satisfies this condition. So, yeah, it exists. All right. Then, but you can always explore a lot of things. I mean, why not? Let's move on to this one. I think this is going to be my final question, right? Is it? Okay, it's still a question on 2021. So that means that I've solved all the 2021 questions. You can give the other ones a try, okay? And then, I mean, check the answer with the marking scheme and you should be fine. All right. So, yes, to conclude on this, since the absolute of this is less than 1, I mean, it exists. Let's go on. The first 3 terms, all right, of an AP are these. Show that the common difference can be written as that for 3 marks. Okay. Common difference is 1 over Q minus 1 over P. All right. And this should be the same as negative 1 over Q, all right, minus 1 over Q. So you are just finding this minus this is the same as this minus that. So what is left is with algebra. So we can have P minus Q over QP on the left-hand side. And this one we are going to get negative Q minus negative Q over Q, right? Or just Q squared. Why will I even do that? I mean, it's just too much. Why don't I just write negative 2 over Q? All right, sure. Then the next thing would be, hold on. What do they want us to do? They want us to get this. Okay. Okay. So can I just multiply, both cross multiply, so that I have PQ minus Q squared is equal to negative 2QP, right? Okay. Then what if I factor out Q, because it happens that Q runs through. So I have Q out, I have P minus Q is equal to negative this, so that this Q cancels that, and I'm left with P minus Q is equal to negative 2P. Okay. All right, I think we are getting what we want, right? So I can move this to this side and then bring the Q to that side. So that means I have 3P is equal to Q, right? Cool. But what can I say about, right? So now I have my 3P showing up here nicely, and it shouldn't contain a Q, right? That's one thing that we should have in mind, that it shouldn't contain a Q. So if it's not going to contain a Q, then what can we do? Is there a relationship involving a Q that we can quote? Let's see. No. So we let's say we are stuck here for a minute. But is there another way we can have this thing without suffering? Yeah, we know Q is equal to 3P, right? So can we change everything here? All right, let me use green to go around it. Okay, that is Q. Q is the same as 3P. So I'll just put 3P there. So I will just hold on to this. Right, it's equal to, you see, you have negative 2 over what? Q. And I say my Q is 3P. So I know that whatever I have is common difference, whether it is on the left-hand side or the right-hand side is common difference. So in this case, I have proven that the common difference is this. It's a tricky question, I hate it. But I mean, that's how you will solve it. Then they tell us that the 10th term of this GP is that. So we should find that K. Well, the 10th term is going to be A plus 9D. But what is your A? Your first term is 1 over P. So let's write 1 over P plus 9 times the common difference, which is negative 2 over 3P. All right. So did they give us anything that we can work with apart from this? Not really. Because even if we simplify, we are going to get 1 over P is equal to negative 6 over P, right? Which is going to give us negative 5 over P. Okay, we are going to get that negative 5 over P. But how would that help us? The 10th, okay, so this 10th is equal to K over P, right? That's what they're saying. So we can equate this to K over P. So now, if this is the case, then we can confidently say that, if P is equal to P, then K must be equal to negative 5. So K is equal to negative 5. Or you can just cross multiply and find K, which should also give you negative 5. All right. Then finally, they are telling us that, that's the B part, right? Sure. They said that the sum to infinity of a GP is 8. All right. That's the sum to infinity. And then the common term, the second term is that. So we should find 2 possible values for the common ratio. Now, the fact that they are saying you should find 2 possible values for the common ratio means that we should actually get 2 values. If we don't get it, then we are wrong. All right, so you know that the formula for the sum to infinity is A over 1 minus R. Okay, and they said this is 8. Okay, so you have established a nice equation, but you don't know the first value, right? You don't know the A. That's fine. But they told us that the second term, U2, which is AR, is equal to 1.5. Okay, so now you have 2 equations. We can call this equation number 1. We can call this equation number 2. And then we are going to solve it simultaneously. So from equation number 1, you can say A is equal to 8 into bracket 1 minus R. Right. But from equation number 2, you know that A is the same as 1.5 over R. So you can now substitute this A here. And you can have 1.5 over R is equal to 8 into bracket 1 minus R. So you can have 1.5 is equal to 8R into bracket 1 minus R. 1.5 is equal to 8R minus 8R squared. So 8R squared, all right, minus 8R plus 1.5 should be equal to 0. This is a nice quadratic. Then what you want to do is to solve it simultaneously. Okay, you can use, I said something, sorry. Not true, just use this quadratic formula. That's negative into bracket 8 plus or minus square root of negative 8 squared minus 4 into 8 into 1.5, right, all over 2 into 8. Have I made a mistake anywhere? This comes, this, that. Okay, that's fine. So we do that. So this will be 8. Normally I'll put this on the calculator and wouldn't worry myself. I don't know why I'm even trying to solve it generally. But I mean, in the exam, please and please again, make sure that you show working whenever you are solving a quadratic. Okay? Because there are marks for that. But here is YouTube. No one is going to penalize me. All right, so that's square root of 16. Okay, so that should be 4. So you have plus or minus 4 over 16. So your first R will be 8 plus 4 over 16. And your second R is 8 minus 4 over 16. That will give you 8 plus 4 is 12 divided by 16, that's 3 over 4. And then the second one will be 8 minus 4, which is 4 divided by 16, which is 1 over 4. So these are the two R values that you are looking for. And this, you do all this for your 5 marks. All right, so you should continue with the solution. We've done about 41 minutes. I mean, that's a lot. So I have a lot of questions here that you can, solve. You check with the scheme, all right? Because I left the years there for you to work with. So, do it, check with the scheme. If you are correct, that's fine. If you are wrong, just put the question in the comments. I'll check it out and then get back to you, all right? All right, so until we meet again, take care of yourself. The next video that I'm going to upload after this one will also be on series, but I'll be concentrating on the binomial theorem. All right, bye for now.